Hello and welcome to the Daily Space. I am your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put science in your brain, or at least plans for spacecraft to do science in your brain. Tomorrow, the OSIRIS-REx mission is going to do a final close flyby of the asteroid Bennu. Back on October 20th, the mission collected a sample of the asteroid and discovered while trying to bounce off its surface that its surface isn't entirely solid. The mission accidentally plunged half a meter into the asteroid before its thrusters could reverse its motion. This is my favorite story of the year. Tomorrow, during an almost 6-hour imaging sequence, OSIRIS-REx will obtain high-resolution images similar to the initial mapping images it obtained in 2019. I, for one, am looking forward to seeing if OSIRIS-REx left a crater on Bennu or if the rocks simply flowed back in like ball pit balls to, well, hide the hole the mission made. Hopefully, initial images will be released later this week. This is OSIRIS-REx's final high-res imaging run, and on May 10th, the mission will begin its journey home. In September 2023, we can expect its samples to get returned to Earth.
While OSIRIS-REx does its thing at Bennu, over on Mars, the Perseverance rover has deposited its companion helicopter, Ingenuity, onto the Martian surface, and teams are now carefully running checks and making sure Ingenuity can get a good solar charge before it attempts its first flight no earlier than April 11th. The current plan is to just try and fly over a 10 meter by 10 meter region that is flat and boulder free. Hopefully, next week we'll have images to share.
From space hardware, we now turn our attention to space objects with an update on the interstellar comet 2I Borisov. Back in the before times, in fall 2019, amateur astronomer Gerardy Borisov discovered a comet passing through our solar system on a trajectory that indicated it's a visitor from some other star system. Since then, astronomers have used every possible telescope to observe Borisov in as much detail as possible. According to Lyudmila Kolokolova, the arrival of 2I Borisov from interstellar space represented the first opportunity to study the composition of a comet from another planetary system and check if the material that comes from this comet is somehow different from our native variety. One of the involved telescopes, the giant VLT in Chile, has revealed that Borosov appears to have received minimal weathering from solar wind and radiation and preserves the composition it was formed with. According to study lead author Stefano Bugnulo, 2I Borisov could represent the first truly pristine comet ever observed. This work appears in Nature Communications. Co-author Alberto Cosolino adds, the environment in which 2I Borisov originated is not so different in composition from the environment in the early solar system. Currently, Comet Borisov is racing out of our solar system and is beyond the ability of a spacecraft to readily run down and sample or observe. In anticipation of future discoveries of alien comets, the European Space Agency is planning to launch Comet Interceptor in 2029, which will have the capability of reaching another visiting interstellar object if one on a suitable trajectory happens to be discovered.
This comet and its similarity to objects in our solar system is a reminder that science really does work the same everywhere. And we can see familiar sights in some of the least familiar places. In a new paper in JGR Space Physics, led by Vincent Hugh, researchers describe a new aurora discovered glowing in Jupiter's high latitudes. Hugh explains, we think these newly discovered faint ultraviolet features originate millions of miles away from Jupiter, near the Jovian magnetosphere's boundary with the solar wind. The solar wind is a supersonic stream of charged particles emitted by the sun. When they reach Jupiter, they interact with its magnetosphere in a way that is still not well understood. Jupiter's powerful magnetic field is driven by its speedy 10-hour rotation. This field prevents solar particles from directly triggering Aurora, as happens here, but particles may somehow be channeled through the field to these observed ring aurora. It's still not well understood. This is something new and beautiful discovered by the Juno mission, and more data and modeling are still needed. After the break, we'll be back to discuss newly discovered super high energy photons that our galaxy's core is blasting our way.
One of the problems with the electromagnetic spectrum is that at a certain point, we just kind of stop naming things. Photons, the particles that make up light, come in a lot of different energies that our eyes perceive as color, our skin perceives as heat, and our radios convert into music. Those photons we see with our eyes get grouped by color in the visible spectrum: red, orange, yellow, green, blue, indigo, violet. Sunburns, they do a good job highlighting the UVA and UVB ultraviolet parts of the spectrum. Beyond that, medicine highlights the use of X rays, and catastrophic nuclear events teach us about gamma rays. And really, anything higher energy than X rays, we call gamma rays. Anything higher energy. And there are a whole lot of energies beyond X rays that we are lumping together. Gamma ray light comes from a lot of different sources, none of which happen to be beakers in labs that can produce Spider Man. Now, one of the most common sources is particles getting accelerated to high velocities and then hitting something. That sudden conversion of kinetic energy from the motion gets converted into a myriad of things, including high energy gamma ray light. In astronomy, rogue high energy particles are called cosmic rays. This name can get a bit confusing because high energy, like gamma ray, doesn't really have a clear definition. If your home is built on granite bedrock, you may have radon in your basement and cosmic rays creating bright spots on camera images you make in your house. This is because radium 226 in granite and other rocks can decay, releasing zippy little protons and helium nuclei in the process that is basically creating high energy cosmic rays from our own planet. But this is for a very small value of high energy. These aren't particularly high energy. They don't generally cause gamma rays to form, but they are still called cosmic rays. Okay, so now you know. There are many reasons why astronomers shouldn't be allowed to name things, lack of clarity or over clarity generally being the problems. On the other extreme, some supernovae, jets from stellar mass black holes and neutron star accretion disks, and other situations with massive magnetic fields. These situations can accelerate protons to noticeable fractions of the speed of light, and when those particles hit things, they can generate gamma ray photons. And we now know, thanks to a new paper in Physical Review Letters, that if you move from the powerful magnetic fields associated with stars to the more powerful magnetic fields associated with the supermassive black holes in the centers of galaxies, you can produce even higher energy protons. And in our galaxy, they produce gamma rays with such high energy that researchers made up a new word: PeVatrons. Essentially, cosmic rays from the Milky Way's core produce gamma rays with energies measured in peta-electron volts. While some of these cosmic rays are inevitably hitting our world now and then, that's not how they were detected. Instead, researchers from the Tibet ASγ Collaboration detected PeVatrons from the gas along the Milky Way. Cosmic rays originating in the core of our galaxy flew across the galaxy to hit gas along the galaxy's arms. Those collisions produced PeVatron energy gamma ray photons that then traveled across the galaxy until they hit our atmosphere. and triggered a detector on the Tibetan plateau. And now you know. There really is no limit to just how much energy one particle can have. We just stop naming them after a while, at least until they are found. PeVatrons, we welcome you to the gamma ray part of the spectrum. After the break, we will be back with some less unclear science. Stay tuned.
Let's come back to our own solar system and talk about another mission to the red planet, NASA's InSight. We've been calling it that for so long now that even I have forgotten it's an acronym. Interior exploration using seismic investigations, geodesy, and heat transport. This mission is designed to search for answers about the interior structure of Mars and the planet's formation, evolution, plus gather data on tectonic activity and meteorite impacts. InSight was launched in May 2018 from Vandenberg Air Force Base here in California. It took 6 months to get to Mars and landed on November 26th. Upon landing, InSight had to unfurl all its solar panels, which are two fan-like discs on either side of the lander. Then all the other instruments had to be checked out and tested. Pictures of the landing site were taken, and it took about 10 weeks before the real science began. One of those instruments is a seismometer named SEIS, for Seismic Experiment for Interior Structure, because everything needs an acronym. Atop the instrument is a protective dome to spare the instrument the effects of wind and temperature. In the first year alone, SEIS detected more than 450 seismic signals, most of which were Mars quakes. The largest of those was about a 4.0 in magnitude. Interesting in and of itself, but not big enough to travel below the crust and into the mantle and core to give us any information about Mars's interior. We know that Mars doesn't have tectonic plates like Earth, but it does have volcanically active regions, and those regions can cause Mars quakes. During that first year of operations, InSight detected 2 quakes in the Cerberus Fossae region that measured 3.6 and 3.5. And just this past week, NASA announced that InSight detected 2 more strong quakes in the same region, measuring 3.3 and 3.1 magnitude. They're still not big quakes, but they are very clear signals that lead scientists to believe that this region is a center for seismic activity on Mars. What makes these 4 quakes so interesting is that they are Earth-like quakes. Researchers have divided the Mars quakes into 2 distinct types based on their physical properties, such as course of travel. Earth-like quakes travel directly through the planet, while moon-like quakes tend to be more scattered. Honestly, most Mars quakes have tended to be a bit in between the 2 types, but these four are definitely Earth-like. Another fascinating piece of these most recent detections is that they were, like the previous 2 quakes, recorded during the Martian northern summer. Winter on Mars is windy-ish. The dome on the seismometer does cut down on the wind, but that wind is noisy enough that the vibrations caused by it obscure any Mars quake detections. Over this past Martian northern winter, no quakes were detected at all. Once the winds quieted down, we heard these 2 new quakes. We mentioned that the dome also protects the seismometer from Martian temperatures, which can fluctuate from minus 100 degrees Celsius to 0 degrees Celsius. While the instrument is protected, those extreme variations lead to popping sounds and even spikes in the data. So the mission team is trying to insulate the cable from the weather by using InSight's robotic arm to drop Martian soil on top of the dome. The soil then trickles down to cover the cable and provides some more insulation, but doesn't interfere with the shield's seal with the ground. This mission is kind of amazing because they keep having to problem solve from a distance. First, there was the mole that was trying to dig underground, but the dirt wasn't a good consistency. They tried everything they could before they finally stopped that portion of the mission. Now they're trying to improve an instrument on another planet using only the lander and the surrounding dirt. And they're about to combat another force of nature, Lack of sunlight. The solar panels, like those of Spirit and Opportunity before, are covered in dust, and Mars is moving away from the sun. It's expected that InSight will hibernate until after July, but the SEIS team is hoping to keep their instrument on for another month or two. As always, we'll bring you updates on the analysis of these quakes and the status of InSight this summer as they are published. We'll be back in a moment to talk about things hitting other things, or not. Stay tuned.
Okay, time to talk about space rocks and how they sometimes attack. Several years ago, there was a whole lot of excitement that Earth just might get hit by the asteroid Apophis if its orbit turned out to be just right. Well, March 8th through 10th, its orbit and Earth's came together, but at a healthy distance, and new measurements determined that it will not hit us in 2029, 2036, or even 2068. Beyond that, there's still some risk. This 350 meter across asteroid is just big enough to do a lot of damage if it collides. And its Earth crossing orbit crosses a bit too close to Earth for comfort. Earth crossing just means the orbits intersect. It doesn't mean the objects intersect. In a best case scenario, an asteroid crosses Earth's orbit when the Earth is far away, like the other side of the sun far away. Apophis, however, likes to get close and will endanger satellites as it flies beneath all the geostationary weather and communication satellites in 2029. With this new data, Apophis has been removed from the potentially hazardous to humans list. And I wait eagerly to see if we are able to get any cool images of it from weather satellites in 2029.
We aren't always this lucky with asteroids. We suspect our own moon was formed when a Mars-sized object hit the proto-Earth and generated a splash of lighter weight material that formed the moon while the heavier bits of both objects stayed together to make up our own Earth. In a new paper in Science, scientists used seismographic maps of the Earth's innards, maps like InSight is trying to make of Mars, to identify 2 continent-sized layers of rock buried deep inside the Earth's mantle. These structures are unusual, and according to the article summary, they, quote, simply have crystallized out of the depths of Earth's primordial magma ocean, or they might be dense puddles of primitive mantle rock that survived the trauma of the moon-forming impact. But based on new isotopic evidence and modeling, lead author Yuan believes the structures are the guts of the alien impactor itself. We aren't in a position to go digging, but it is cool to think that there may be shrapnel still intact in our world. This work was presented by lead author Qian Yuan.
Since that fateful impact, rocks have continued to fall out of the sky in a variety of sizes. And sometimes they explode in the atmosphere instead of hitting. This happened over Tunguska, Siberia in 1908 and over Chelyabinsk, Russia in 2013. And it has probably happened many other times over places that had fewer humans to notice. One of those times appears to have been about 430,000 years ago over modern day Antarctica. Researchers exploring the summit of Wilna-Flaget within the Chauve-Rodienne Mountains in eastern Antarctica found myriad small, weird nodules that appear to have come from an object bigger than your typical airburst, but that didn't create a crater on the planet. This research is published in Science Advances with lead author Matthias van Genneken and shows that medium-sized asteroids can be dangerous in a new way. They can literally explode as a massive cloud of tiny rocks in what are being termed touchdown events. According to Van Genneken, while touchdown events may not threaten human activity if occurring over Antarctica, if it was to take place above a densely populated area, It would result in millions of casualties and severe damages over distances of up to hundreds of kilometers. This is a reminder: space will try and kill us, and we're still discovering all of its weapons. This has been the Daily Space. Join us again tomorrow for our weekly Rocket Roundup with Annie Wilson.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.
Thank you, everyone.